All right, welcome, ladies and gentlemen. This is naming video number 2. It's on writing formulas for ionic compounds. I have to apologize for my voice, but I think you should still be able to hear me. So you're going to need your notes open to page 19. So it's all about writing formulas for ionic compounds. So this is opposite of what we've been doing because now I'm going to give you the name and I'm going to ask you for the formula rather than giving you the formula and asking you for the name. The absolute critical part of this is that before you go to actually writing the formula, the first thing that you do is you write down the symbol and the charge for both the cation and the anion. That's critical. Never, ever, ever go straight from the name to writing the formula. Always, always, always write out both the symbol and charge for your cation and your anion. And then the key is that charge has to balance. So you never know if it's a 1-to-1 or a 1-to-2 or a 2-to-3 ratio. It's all about getting the charge to balance. So that means that the total charge of both the cation and the anion, they have to add to 0. So if like one is +1, the other is -2, then you need to have subscripts to say more than 1. Right, overall charge is equal to 0. We call this, and there's a method to do this to make sure that that charge is adding to 0 quickly and easily, and it's called the crisscross and reduce method. And in the crisscross and reduce method, what you do is take the charge of the cation and you turn it into the subscript for the anion. There's no plus or minus sign, you lose that, but you just take the number. So if it was +1 for the cation, that means that the subscript for the anion would be just 1. And then you do the opposite, meaning you take the charge of the anion, let's say the charge of the anion is like -2, and make it the subscript for the cation. So it would just be, again, 2. So there's no plus or minus. And those become your subscripts. Then you look at your subscripts, and if you can reduce them down, you do. And there you go. That's your formula. And check to make sure your charge is balanced. Now, when you're doing this, there's a key point here. For nonmetals, if we're talking about binary compounds, then you want to use the first charge listed on your reference table because that charge listed is for following the octet rule for gaining electrons to get to 8. So we want to use that first charge listed for if it's a binary compound. So for example, iron 3 oxide. We want to write the formula for iron 3 oxide. So the first thing that we want to do is write the formula for each of the ions. And now iron 3 is Fe and its charge is +3 because that's what the Roman numeral means, right? The Roman numeral here is telling me the charge. Oxide, what's that? Well, if it ends in IDE, that's a massive sign that it's a monatomic ion. Right, that's a massive, massive tip-off. So it's just oxygen. And we want to use, we know it's -2 because we want to use the first charge that's listed on the reference table. So notice I'm not going straight to the formula. I'm writing out the individual ions. That's really, really crucial. So now, if I want to write the formula, I'm going to take the charge for the iron, which is the 3, and I'm going to make it the subscript for the oxygen. So the subscript for the oxygen is actually going to be 3. And then I'm going to do the opposite process. I'm going to take the charge on the oxygen, which is 2, and make it the subscript for the iron. So that means that the formula is Fe2O3. That's the formula for iron 3 oxide. Then we want to see if we can reduce. Well, you can't reduce 2 and 3 down any further. So that's it, right? You can't reduce them and have them still be whole numbers because their subscripts are always going to be whole numbers. And then we just want to do a little bit of a check. Check the charges. Should be 0 in all. And it is because 2 irons, that's the 2 right there, and the charge on the iron is +3. That's where that's coming from, right? That's +6. And then for the oxygens, there are 3 oxygens, that's the subscript, and the charge on the oxygen is -2, so 3 times -2 is -6. So they balance one another out. With ionic compounds, it's all about charge cancellation. So just another example, we're going to do magnesium oxide. Never go straight to the formula, always write out charges first. That's really critical. So what's magnesium? That's Mg. What's the charge? It's +2, so I'm going to write that out. Oxide, we already did that, that's O2-. So crisscross and reduce. Take the charge on the cation, make it the subscript for the anion. Take the charge on the anion, make the subscript for the cation. Lose the plus and minus, just keep the numbers. So I get Mg2O2. But here's the thing, I can reduce that down, right? Because the idea is that these guys are in a 1-to-1 ratio because +2 cancels out a -2. So the actual formula is just MgO. So it's crisscross and reduce. It's just a 1-to-1 ratio. If you told me that the formula is Mg2O2, that's wrong. That's not the formula for magnesium oxide. That would be incorrect. So it's looking at the ratios and realizing that we only need 1 of each. Check, do the charges cancel? Yes, they do, right? Plus 2 cancels out with a minus 2, so we're good. So writing the chemical formulas, and we just have a couple of other examples so that you hopefully feel pretty comfortable with this. Barium nitride. So barium, what's that? That's Ba. What's its charge? It's plus 2. Nitride, that "ide" again means monatomic. So I know nitride, that means nitrogen, so that means N. What's the first charge listed for N? That's minus 3. So I'm going to take the 2, put it there, take the 3, put it there, and the formula would be Ba3 and 2. So that's the formula for barium 3 nitride. I'm sorry, barium nitride, Ba3 and 2. Manganese 7 oxide. What's manganese? That's Mn. What's the charge on the Mn? It's plus 7. How do I know that? That's the Roman numeral. That's what the Roman numeral means. Oxide, what's that? That's oxygen. Again, it's monatomic because it ends in "ide." First charge listed for oxygen is minus 2. I don't use the plus or minus, I just use the number. So the 7 is going to become the subscript for the O. The 2 is going to become the subscript for the manganese. So the formula for manganese 7 oxide is Mn2O7. And I can't reduce those down any further, right? 3 to 2 for the barium nitride and 2 to 7 for the manganese oxide. That they're as far as they can go. What about if we have a polyatomic ion? We use the exact same process. We use literally the exact same process, but now we're using table E to get the charge on the polyatomic ion. Table E is your friend. Table E tells you formulas and charges, so table E is a good thing. So we also, if we have more than one polyatomic ion, we use parentheses. Put the polyatomic ion in parentheses if we have more than one of it. So for example, calcium nitrate. Again, never go straight to the formula, always write out charges. Calcium, what's that? That's Ca, right? With charge is plus 2. Reference table tells us that. Now if it ends in 8, remember that's a 8 or ite. That's a massive, massive sign that you're going to be looking for table E. So if it ends in 8 or ite, go to table E. So calcium is plus 2. The nitrate is negative 1. Again, table E is telling me that. So you're writing down the NO3 and you know that its charge is negative 1. Now, excuse me, you're going to have to take the charge for the cation and make it the subscript for the anion. So, but this means now that the 2 is going to go on the outside of the parentheses. So I'm going to have a 2 there. I'm not a minus 2, just a 2 right there on the outside of the parentheses for the NO3. And the charge on the anion, which is negative 1, but I'm just going to lose the minus sign and make it a 1. So that means that the formula for calcium nitrate, crisscross and reduce, and I can't reduce it down anymore, is CaNO3 parentheses 2. It's very important that you put the parentheses there, because if I said NO3 2, well, now it looks like the 2 only applies to the oxygen and not the nitrogen, and that's not true. It applies to both of them. So we need to put it in parentheses so that we understand that it applies to both the nitrogen and the oxygen. So just a couple of other examples, potassium phosphate. So we write the formula and the charge. Potassium, that's K. What is its charge? Plus 1. Phosphate, again, that 8 ending, massive sign that you're going to table E. So we look up phosphate in table E. We look it up, and it's PO4. I'm going to put in parentheses. And what's its charge? Its charge is negative 3. So I'm going to take the 1. I'm going to put it on the outside of the parentheses here. I'm going to take the 3. I'm going to put it next to the K. And I get the formula K3 parentheses PO4 1. But we actually can simplify that in chemistry. If there's only one of a polyatomic ion, we don't include the parentheses. It would just be K3PO4. Sorry, my smartboard's having a moment. And then the other one, chromium 3 nitrite. You want to start by looking up the, sorry, let's just finish that up. K3PO4, right? Chromium 3 nitrite, write out the symbol and the charge. So chromium is Cr, its charge is plus 3. Again, how do I know that? Because that's the Roman numeral. Ends in ite, massive sign that you're looking to table E. So you look that up, that's NO2. What's its charge? I'm going to put in parentheses, what's its charge? Its charge is negative 1. Switch to the crisscross and reduce. So from that I get Cr, parentheses, NO2, on parentheses 3. So there we go. So we're going to practice with this in class.